Greetings, detectives. Mrs. McKay here, and it's time for Case 7, Shady Inequalities. And our first clue is all about graphing inequalities. So let's go ahead and fill in our learning target. I can graph, make sure you write this down, a two-variable inequality. And just so you understand where you're graphing it, go ahead and write on the coordinate plane. And I want to get started by looking at some of our vocabulary. Our first word is the word boundary. Now I'm sure you've heard the word boundary, and a boundary is just a division. It divides two parts. And so we might have a fence that divides 2 yards, or makes the division between my yard and my neighbor's yard. Or a boundary of a state line is the division between California and Arizona. If I cross the boundary line, I'm no longer in California, I'm now in Arizona. So a boundary is going to be used in math to divide the coordinate plane into 2 halves. And we call the halves of the coordinate plane a half plane, each one a half plane. So there's 2 half planes on the coordinate plane. Okay? And we're going to actually see how those half planes, one of them has every point that makes a solution to our inequality that has 2 variables, x and y, and the other does not have any solution. So we're going to be able to shade that half plane to show that it is the solution to the inequality. All right, let's get started. Underneath testing points, we have a little problem here. Each person in the fundraiser has to sell enough cakes and cookies to raise more than $8 each. Cakes sell for $4 and cookies are $2. So we're going to write this as an inequality. So let's think about how we could write that. Well, I have it written right over here. I have 4x plus 2y is greater than 8. So our x is the number of cakes that we can sell, and 4 is the amount that we make for each cake. So 4 times x would be the amount of money that we make for selling cakes. And since cookies are $2 each, 2 times y must be the number of cookies. So I have 4x plus 2y would be the total amount of money that I would make as a person trying to raise money. And I need to make more than $8. Notice that I can't make $8. I have to make more than $8. So I have this inequality written, 4x plus 2y is greater than 8. Now the question is, how many cakes and how many cookies can I sell? How many different combinations can I sell to come up with the amount of money that I need to make, which is more than $8. So I'm going to test a few points here. I have 3, 3, 0, 2, 2, 4, 1, 0. We're going to try each one and see. What happens if I sell 3 cakes and 3 cookies? Why don't you go ahead and see if that is a true statement. Can I sell 3 cakes and 3 cookies and make more than $8? Go ahead and write it out in this box and decide if it's true or false. So I said 12, I did 4 times 3 is 12, plus 2 times 3 is 6, 12 plus 6 is 18. 18 is definitely greater than 6. So that is a true statement. All right, now let's try. So that means I can sell 3 cakes and 3 cookies, and I will have met my minimum of more than $8. All right, let's try another one. What if I sell 0 cakes and 2 cookies? Figure that one out. Is that a true statement? So I did 4 times 0 plus 2 times 2. I got 0 plus 4. 0 plus 4 is 4. Is 4 greater than 8? No, it's not. So we're going to say no, and it is false. All right, let's try the next one. 2, 4. 2 cakes, 4 cookies. Well, I came up with 8 plus 8 is 16 is greater than 8, which is definitely a true statement. So I can sell 2 cakes, and 4 cookies, and definitely make more than $8. Let's do the last one. Can I just sell 1 cake and no cookies? Well, you can see right away that with only selling 1 cake, I'm only going to make $4, and no cookies, that's 0. 4 plus 0 is 4. 4 is not greater than 8, so that is false. So I've just tested a few points to see which ones will work and which ones won't. But do I know all of my combinations? No, I don't, but I can graph them. I can do a graph and see all of the different combinations of cookies and cakes that I can sell. So let me show you how you do that. So I have a new inequality, and we'll go back and we'll graph the other one later if we have time. If not, you can graph it. But here I have a new inequality, and it's 2x plus 3y is greater than 6. Now the way that I do that is, you know what? I changed my mind. I do want to graph this one, but we just won't worry about this other one, or if we have time, we'll do it. So I've rewritten 4x plus 2y is greater than 8. Now, I want to figure out where all these points fit. So I'm going to go ahead and start by graphing some of these points. So 3, 3. We said 3, 3 was a true statement, so I'm going to make that one be green. So 1, 2, 3, 1, 2, 3. Right there, 3, 3, 3 cookies, 3 cakes. That's definitely on the true side. And so is 2, 4. So I'm going to do 2 and 1, 2, 3, 4. So that's going to go right there. And then 0, 2 and 1, 0 were not. So I'm going to make those be red. Let's see. 0, 2 and 1, 0 were not. So you can see that they're sort of separated. And there must be a line that I can draw somewhere along here that is sort of the division between making enough money and not making enough money. And I think I can figure it out by just thinking about, what if I sold 0 cookies? If I sold 0 cookies, 4 times 0, could I figure out how many, if I sold 0 cakes, X is my cakes, then how many cookies would I have to sell to make more than 8? Well, I would have 2y is greater than 8, so y would have to be greater than 4. So that means the point 0, 4, which is just my y-intercept, is going to be right up here. 1, 2, 3, 4. So everything greater than 4 up this way should work, right? And then what if I sold 0 cookies? How many cakes would I have to sell? Well, then I'd end up with 4x is greater than 6 if I put 0 in place for my cookies. And that would be, let's see, divide by 4, 6/4 would be 1.5. So I'm going to say 1.5, 0 would be right there. And that means everything, the number of cookies, would have to go this way. All right? So now that means that I have 2 points, my x-intercept and my y-intercept, and I can just simply connect those 2 points like this. And that means I've drawn a line, and everything that's above that line should be true. Everything above the line should make my problem true. That means if I picked this point right here, which is 2, 2, if I sold 2 cookies and 2 cakes, I would get 2 times 2 is 4, plus 3 times 2 is, sorry, not that one right here. 4 times 2 is 8, plus 2 times 2 is 4. That would give me 12. 12 is $12. I would make more. So really, it's everything above this line. All this area right here would make this be a true statement. But the question is, would anything on that line make it a true statement? And we already know 2 points on the line. This one right here, which was 0, 1 1/2, and this one right here, I'm sorry, 1 1/2, 0, and this one was 0, 4, we know that those two will not be included, that's not enough money. That's only $8. So I can't include that line. So that means that I need to do something different when I'm graphing this. And the way that I make sure that I keep something, that I say that my boundary line is not part of the solution, I make it a dashed line. So I'm just going to erase some of this line and make it be dashed. So the line, the equation, 4x plus 2y equals 8 is actually the boundary line, okay? It's actually the boundary line, but because the points on the boundary line aren't included in the solution, I make them be a dashed line. But everything above the line can be shaded because that shows me that those are the solutions. Each point is a solution to my inequality. All right? Now, let's go ahead and look at this little dotted box over here, graphing inequalities on the coordinate plane. It gives me the 4 steps of how to graph an inequality. The first thing I have to do is I really need to just graph the line, graph that inequality as if it was a line. And I can use any method I want. I can use x and y intercepts, which is what I did here. Or I could turn the line into slope-intercept form and graph the line that way. Either way, it doesn't matter. Then I have to decide whether my line is going to be dashed or solid. Now, I didn't give you an example of it, but really, if the line, you can kind of think about this, if the line is going to be included in the solution, that's when it's going to be a solid line, and that's when you have something that is greater than or equal to, less than or equal to. The equal to part of the inequality makes the line be a solid line because it is part of the solution. Then we have to test a point, and I'll explain that in a minute. And then we shade the half point. We actually did test a point. We tested 2, 2, but I can show you how we can do this without having a problem that we're solving, but just looking at it. All right? So let's do this one. 3x minus 5y is greater than or equal to 15. Now, what I'm going to do this time is I'm going to turn this into slope-intercept form. So you go ahead and take this and also turn it into slope-intercept form. So I turned this into slope-intercept form and I got y is less than or equal to 3/5 x minus 3. If you want to go ahead and pause it and just take a look and see if I did my math correct, great, but I'm going to go ahead and graph this line. So this boundary line is going to, the equation of it is y is less than or equal to, or y is equal to 3/5 x minus 3. So here's my -3. That's my slope, that's my y-intercept. I'm going to go up 3 and over 1, 2, 3, 4, 5. And now I have 2 points that I can connect to make a line. And that will become the boundary, that's the division of my half plane. I know that it's going to be a solid line because it is less than or equal to, which means that the line itself is also included in the solution, where up here it wasn't. Now I just have to decide if my line should be shaded above or below the line. And there's 2 ways that I can do that. I can actually, if I have it in slope-intercept form, if I have y is less than, then I know that my y's all have to be below the line, less than the line, okay? But there's another way that I can do that, and that is to test a point. And that is, I put my 0, 0, this point 0, 0, I put it in place. 0 minus 0 is 0 greater than or equal to 15? No, it is not. So 0, 0 is not a solution point, but that means this side, the above the line, is not the solution. Below the line is the solution. So that's where I'm going to shade. So every point below this line is a solution for this. Okay? Go ahead and fill in over here where it says boundary lines. If you have less than or greater than, it's dashed. And less than or equal to or greater than or equal to is solid. That's it.